Okay, looks like we're good to go. So as you can hear, guys, in the background, we have Centrac, and it's because of the title. Did anybody paid attention to the abstract for this talk? Do you know what you're getting into? Did you figure out that there were plenty of song reference of Daft Punk in that abstract and didn't mention anything at all about Gradle? Okay, so this is it. My goal for today is that for those of you that have not used Gradle so far, give it a try today. And eventually you'll find out that using Gradle versus the other build tools that you have a choice, you pretty much will feel like this. You're partying, you're having fun, things actually work. We'll see. Okay, so my name is Andres Almiray. I come all the way from Mexico, but actually living right now in Switzerland, so that trip wasn't that bad. I work for a company called Canoe. We do lots of Groovy and Java related projects. This is one of the reasons why I'm here. We work with many technologies and we like to showcase what we do. And Gradle happens to be one of the tools that we have chosen to build our projects. I'm also a Java 1 champion. I am Java 1 rockstar. I'm a Java champion. I'm a member of the Groovy development team. So I know a few things about Java and a few things about Groovy. If you have any questions during the talk, just let me know, raise your hand. I will leave some time at the end, but if you have a burning question in your mind, please don't wait until the end and just pop it immediately. And there are no stupid questions. We're here to learn. So, quick poll, who has used Gradle already? A few hands. Who uses Maven every day? Keep your hands raised. Do you love using Maven? Just a few hands. It's because it's what we have. Is anybody still stuck using Ant? Oh my God. Anybody here uses Builder? Rake? God forbid SBT? Oh, good. Okay, so Gradle is a build tool that is designed to take conventions into account, because if you look back at the history of build tools in the Java space, first we didn't have anything. Then we had Make, and it was really a pain to build a project that was supposed to be built in different platforms or across even different machines, even if it was the same platform. So Make didn't cut it. Then came out Ant, which was really good. It gave us the power of building in every different platform, but you as a developer had the responsibility of defining every single bit that you need to have in your build, which is also good, but it was also a burden. Because the next time you need to create a new project, what do? Copy and paste from a working script, and then change it so magically it will be able to work with your current project. And then the next one, the same. So then came Maven. And Maven, does anybody here remember Maven 1? Yeah. Maven 1 was better because, well, it still had XML. But it allowed you to have conventions and download dependencies. It was really powerful. The problem was, again, XML. Then came Maven 2. And it was much better. It gave us much more conventions. You will download the dependencies. You will have repositories and whatnot. And life apparently was good for a long time. But then things started to break into the cracks. And you will notice that if you follow the Maven way, if you follow the happy path, everything apparently works fine. But if your project deviates from the conventions, yes, you can specify your own conventions, but some plugins don't work correctly. Because even that things are configured, the plugin says, I don't care. I'm going to use the standard Maven convention, so whatever you put, I'm going to disregard. So now you're stuck in trying to do something that the plugins do not allow you to do. And if any of you have ever written a Maven plugin, a Mojo, somebody? Don't. Don't even bother. Don't start. It's okay. So then came Gradle and say, what if we could rethink the basics of Maven, take out what is good about it, and then just remove everything that is not working and put something else. And that's basically how Gradle came to be. So it has conventions, it has configuration, but because of these conventions, it allows you to be very quick. If you follow conventions, good. If you don't, then you start putting configurations. So Uh, the great thing about Gradle, is that it follows the same Maven conventions, which means if you're already in the happy path, and migrating to this build tool should be an easy task. It also has a very expressive DSL, and here may be one of the points why people don't like Gradle too much. Who loves dynamic languages? Just a few hands. Who likes static languages and swears that static languages will conquer everything? Yes, I know. And this is the reason why people don't like Gradle, because it has a DSL that is written using Groovy. Groovy is a dynamic language. Oh, it's dynamic. But it's not XML. That is the best thing. Okay, so the DSL is just the delivery mechanism. What is behind is a real well-thought object model. The Maven object model is a good start, but it lacks many features. The Gradle object model has much better things, and everything is pieced together using Java. It just happens that the final leg is written using a Groovy DSL. Now, nothing stops somebody for creating an XML-based DSL for Gradle. Yes, that can happen. And it's not because it's not tied to Groovy. If somebody really is desperate to go back and use XML, they can do it. It's also extensible because it supports plugins, just like in Maven. I think that the richness of the tool itself is how many plugins you can find to do pretty much anything that you need to do. It's very productive because one of the things that Gradle has that Maven cannot have for now is authentic reproducible builds. You can fix the version numbers of every single plugin plus the transitive dependencies and the version number of the tool itself. So whatever you do today is going to be used 1 year from now, and everything is going to work. How many of you fix the version number of the clean plugin when you're using Maven? The process result, compiler? Now these plugins eventually change whenever you move to a newer version of Maven, and they come from the super POM. Did you know that? If you do not fix all plugin versions, then whatever you compile today and you build it 2 months from now, I can assure you it's not going to be the same. Even in the same machine, with the same JVM, it's not going to be the same. Reproducible builds are not possible in Maven. They can be in Gradle, which is really, really good. And finally, it is convenient. It's very easy for us, developers, to download a build tool, unpackage the zip file, put it in a particular place, and then just start hacking code. But when we need to share this code with our teammates or a CI environment, then these tools have to be installed in those other machines. Now, typically, in a CI environment, what do? You talk to the IT people so that they can provision for whatever version of the tool you need, which may take, I don't know, a couple of hours, a couple of weeks, maybe. And then it's done, and you figure out that you put the wrong version. So you have to kickstart everything again. In case of Gradle, there is already a thing called the Gradle wrapper, which allows you to fix the Gradle version and then kickstart the build with that one. And you don't need to bother IT to make this happen. It's something that you, as a team, as a project developer, can do very easily. We're going to see that in a moment. This is a very, very interesting feature that actually the next version of Maven is going to include it. So you see, it's a good thing to have. I'm going to showcase a little bit of statistics. There is this company that you might have heard of called Zero Turnaround. They have their own things, their own tools, but they have a series of technical reports behind this thing they like to call Rebel Labs. They asked a bunch of developers in 2012 about the usage and statistics for build tools. And this is what they came up with. Now, this is a close to 2-year-old report now. I'm hoping that these guys will create a newer one, because the statistics that they have is until 2013. So you see that Maven pretty much is the dominant build in the marketplace. Everybody knows it. It's kind of easy to understand, and wherever you go, you're bound to find a Maven build. Now look about Gradle. Gradle in 2010 was not known, not much, but then suddenly when they released 1.0, boom, it exploded. Just because many projects at Spring or Pivotal and Red Hat started to use Gradle instead of Maven. And this number is not, or should be bigger, because for those of you, is anybody here that uses Android or actually creates applications for Android? Well, it so happens that you used to have an Ant-based tool. Now it's all Gradle. So pretty much every Android developer around the world uses Gradle, whether they like it or not. I hope that they actually like it. So this number will be bigger. And now let's look at Ant. Ant doesn't have any dependency resolution mechanism by its own. You have to use Ivy, which happens to be a dead project. So if you're still stuck with Ant and Ivy, at the very least, consider migrating to Maven if you cannot go all the way to Gradle. So in terms of different features, the learning curve, Maven is really quite simple. I mean, we all know it. I guess there is not really that many surprises when just using the build tool. I'm not thinking about configuring the whole thing or creating plugins. Just a regular usage is quite good. Now, in the case of Gradle, you will find that you may learn a few things small. It's not just because, again, the Groovy DSL. I mean, okay, I'm going to say it right now. So Groovy is kind of like Java. Take out the semicolons, you got Groovy. It's as simple as that. Yes, it has dynamic typing. It actually has optional typing and a few other features. But as a Java developer, you should be able to pick up Groovy very easily. You don't have to relearn or retrain your brain a lot in order to take advantage of the language itself. But on top of that, you have to know what are the conventions of the DSL, which some of them follow the Maven ones and others are completely different again because the object model is much richer than the previous one. And well, and we're going back to the basics. Oh, okay. What about build speed? I definitely disagree with this one. Maven is actually slower than Gradle because every time, and this is true for every build tool, when you kickstart the build, what happens? A JVM starts, which you have to pay the price for that, and then your build actually runs because you have to load whatever build tools in order for run to the build. Okay, once the build finished, what happens with this JVM? It dies, right? When you kickstart a new build, a new JVM, you pay the price, run the build, off you go. So what Gradle has in order to make builds much faster is a mode that is called the Gradle daemon. It kickstarts a JVM the first time, and this JVM is moving to the background. So the next time you issue a build, you're hitting a warm JVM. So the second build and the third and the next ones are going to be much, much faster because all the classes are loaded. Now, don't worry about problems with class loading and class paths. The daemon takes care of this, and it can be restarted every so often. I think by default it's 3 hours, or you can simply disable the whole thing if you don't want it. It's an optional package, but it's something that allows you to have much faster builds. In terms of complexity, Maven itself is really quite basic. Gradle is a bit more complex because of the fact, as an author, or somebody that really needs to talk with the internals, you might say, well, if I have to deal now with a daemon, how I'm going to send data across different processes, how I'm going to deal with cache and this and that, actually it's very simple. You don't have to consider this. You don't even have to think about these things. They just happen. As a plugin author myself, which I have written much more plugins on Gradle besides Maven, I can tell you right now that it's really very simple. These concerns about the internals don't happen. You don't need to go that far. In the case of plugins, Maven is king because it has had more time for the community to grow. It's just that. But the Gradle community is actually growing pretty fast. And many plugins that you find on the Maven side, you're going to find their correspondent on the Gradle one, and then some others that, for some whatever reason, people don't want to use in Maven. Community and documents, this is the killer of the many things that you're going to find. Documentation in Gradle is superb. Just the official documentation is enough to get you started. And then you will find the documentation of each one of the plugins, and this is now up to the standard of each one of the plugin authors, but most of them are pretty good. Now, when I started my blog back in 26, there was one thing that I wanted to do with my Maven-based projects. I needed to display a logo on the left side of the Maven-generated site. I mean, this is just attaching an image in a particular place, right, and perhaps add some CSS. You wouldn't believe how difficult this is to do. and there is no documentation at all how to deal with the templates because everything is hidden into some Maven template internals. This is one of my blog posts that most people read. How to put an image in the generated Maven side. So if that isn't simple for documentation, imagine what it's going to do for the real things, integrating reports. So documentation in Gradle, the best one that you can find so far. And finally, developer tools integration. Maven again has had more time. So all the major IDEs have good support for Maven. In the case of Gradle, I will have to say that IntelliJ IDEA is the one has the best support now. Second will be NetBeans. And third, well, this used to be the case, will be Eclipse. They had just a release last week, Eclipse Mars, with a new project called BuildShip. So if you are stuck in Eclipse, don't worry, Gradle is going to work much better now. But if you can switch to better tools like NetBeans or IntelliJ IDEA, you're covered. Yes, you can tell I'm a bit biased. I used to be an Eclipse user for 6 years, and there's a reason why I use IntelliJ. So there is a company behind Gradle called Gradle Web, and they used to have this page, or at least this image on their homepage. They just changed the homepage recently. And these are some of the clients that are currently using Gradle. Now, just like Maven, there is a company behind the project and the product, but the project is open source under Apache license, so these guys are there to just keep adding more things, and of course, if you need, you can ask for the services. But just like in Maven, that you don't have to pay anybody, then if you don't like, then just use Gradle for free. It's all open source. A few of the features that you find in Gradle that will perhaps make your builds much faster. The caching of inputs and outputs. I'm going to move directly into some real case scenarios. But whenever you run your build, you'll see that you have to execute tasks or targets or commands, whatever the name is used by the build tool. And when you run the build again, perhaps some of these tasks will be invoked. So for those of you that have configured the Maven side already, do you run coverage for your projects? Cobertura? Clover? Jacoco? Okay, for the guys that said cobertura, this is a simple one. You run your build and you want to generate the site, so what happens? Compiles the project, runs the tests, instruments the code, runs the tests again, generates the Java doc, generates the site, right? So first, why do we have to run the test twice? This is a problem with the Cobertura plugin itself. Because you use Jacoco, they run just once. So Jacoco, much better. But then, you notice that there is a problem in your documentation. You missed something. So you change the documentation. Now you generate the site again. What happens? Compiles the code, runs the test, instruments Cobertura, runs the test again, and Java doc generates the site. Why do you have to do all these things again if you only need change the documentation? So the thing that Gradle knows, it can cache the inputs and outputs of each one of these tests. One of these tasks. So when you run the next build, if the sources didn't change, so there's no need to compile things again. It also means there is no need to run the test again because everything was green before. There's no need to regenerate the Java doc because the sources again didn't change. The only thing I'm going to change is the final output of the documentation because those are the sources that did change. It has a much richer configurable lifecycle. In Maven, we have around 20 phases or so that you can attach yourself. And if you use the Maven side, there are 4 or 5 more. But those are the only phases that you're going to have. Nothing more. There's no way for you to do something in between compile and process resources unless you bind to compile or process resources. You cannot put something in the middle with a new name. There's no chance. Whereas with Gradle, you can have this. There's much flexibility here. I already mentioned the Gradle daemon, and we'll see the Gradle wrapper. Multi-project builds. Managing multi-project builds in Maven is an afterthought. When it was designed in the beginning, it was just for single projects. Then came the Reactor plugin. And it kind of worked, and then it was injected into the core. but it's not a real first-class concern, as you will see in Gradle in just a moment. The plugin development is definitely much more intuitive. I have created plenty of plugins here, and we perhaps can see some of the sources, and you'll see that it's quite simple. And again, I cannot repeat and I cannot stress enough how useful the documentation is. So how do you get this started with Gradle? There are many ways. You download a zip file, put it on the whatever place in your machine, configure your path environment, you're done. Or you download it from the IDE, you're done. I prefer to use things on the command line, so I will download the zip and configure the environment variable. But if you have to do every single time that there's a new release, it gets tiresome. So I rather use this tool called GVM, which allows you to download any version of Gradle and just configure it. It works on any major OS, even on Windows. If you use Cygwin, it will work. If you use PowerShell, there is a version called PushGVM that works with it. If you're not using Cygwin and you're using Windows, I would rather also recommend you to use another shell called Baboon, baboon.io, which is a repackage of Cygwin plus another thing, plus Git for many things. Believe me, it's much better than just plain Cygwin. Okay, say that you have that, you install GVM, it's as easy to install the latest version of Gradle calling GVM install Gradle. If you need to switch to another version, you do GVM list Gradle. It will tell you all the versions that are available to you, and then say, for example, GVM install Gradle version 2.0, and that's how you get the old one. If you need to switch between versions, GVM use Gradle whatever version. And you can even have different versions of Gradle in different shells at the same time, even on Windows, even with Cygwin. So that works. So I'm going to show now. Remember, if you have any questions, just let me know. When I get too excited about the content, I just keep talking, and we only have less than 30 minutes to go here. So say that you have a very simple project like this one. There's a production code, and there's a test code right there, because we know we have to test our code. So what I'm going to show now is a very simple bare bones Maven build file to make this compile and probably run this test. What is important here is to take a note of how much blue versus black. The blue is the important thing about your project. What is specific about your project? The black is just there to please the tool itself. So we got a group ID, what is the name of the artifact ID, the type of packaging, because everything is Java and Maven, whatever version is there, and one dependency. We need JUnit for testing, and it has to be on the test scope, right? Let me show you the functionally equivalent build in Gradle for this. And remember, the important thing is how much blue versus black. Is that so hard to read? Is that so hard to understand, even this Groovy code? That's the whole point of the DSL, that it actually pleases the eyes. So again, this is a Java project. We're going to apply another plugin called Maven Publish, because here's the interesting thing about Gradle. Gradle is a build tool that can build pretty much anything you want. Maven is a build tool that can only build Java-based projects. So if you need to build something that is not Java, perhaps it's Groovy or Scala, apply a different project. As a matter of fact, you can build Objective-C and C++ projects with Gradle. So you may be thinking, okay, that's interesting, but that doesn't apply to me. Why should I care about those other languages? I'm a Java developer. Well, the thing is that the Gradle people have to figure out what is common when building a project itself, regardless of what is the target language. Whereas the Maven people say, well, we're just going to concentrate in this box, inside the JVM, and it's quite good for us. And they took some shortcuts for that. So again, the blue there, in Maven, we always have access to two repositories, Maven Central and Maven Local, so we don't have to define it. In the case of Gradle, because it's kind of agnostic to this, you do have to specify one repository from where you can consume dependencies. This JCenter is much faster than Maven Central, but there's also another method there that you can use Maven Central, just like that, with capital C. Or if you need to use Maven Local, then it's Maven capital L Local. Simple as that. And finally, we define dependencies with a short notation. There's also a longer notation if you want it, but it's quite understandable that this is organization, artifact ID, and version number. There are other ways for you to also specify classifiers and other kind of stuff, but this is basically must it. And notice the test compile scope. In Maven, we used to have test only, right? Now we have test compile, so it's very likely that we may have test runtime. Here's a question for you guys that know Maven. How do you define a dependency that should be used at test runtime only? Should not be used during the compilation of the test, only when you execute the test. How do you do that? What kind of a scope do you use? Good question. There are two options for you. Either you go with system, which bounds the dependency to, it has to be a relative path, otherwise we're going to screw over our teammates and the CI environment, and still puts it in the compile. The other option is provided. It still puts it in compile. There's no way for you to use a test runtime only scope in Maven. No way. But Gradle allows you to do that. Actually, the scope mechanism in Gradle is much richer than that. You can create your new scopes if you need to. So let's see some scenarios. Now we're going to show code. These are the three things that I want to do. Create an executable, launchable application. This means there has to be some main class attribute in a manifest in the jar file. Make it executable fat jar, which means condense all the dependencies in a single jar, taking care of duplicate resources or duplicate classes. And an installable application, package everything perhaps into a zip that I can ship to a customer or a teammate so that I can run the application. So let's go with the first one. I do have the things in the slides, but I can show you the code. Say we start with the same Maven point that we had before. Now we append this. In order to make this an executable application while you're building, not while you want to finally deploy this thing, it's a simple matter of adding a new plugin, the exec Maven plugin. And that's it. And then you define what is the main class that you want to run, whatever class is your fancy. Then you run the Maven compile exec Java. Why? Because if you just run exec Java and you just did a clean, it will not work. Because the exec Java plugin task says, I assume everything is ready for me, I just need to run the project. There are no dependencies within the standard compile phase, which is always there, and the exec plugin for some reason. This is the same thing in Gradle. Make it a Java plugin project, apply the application plugin, define the main class, maybe it has some additional dependencies, and then you simply do Gradle run. Because the run task is aware that I need to run something, right? I need to know which class, okay? So once you have defined it, says, I need the class. Instead of saying that you explicitly have to compile the code and process the resources, it simply defines a dependency on an abstract task that is of type compile. Whether this is Groovy or Java code, it doesn't matter. As long as that compile phase finishes, then this thing is going to continue. An executable fat jar. Let's condense all the dependencies in one jar. Does anybody have done this already in Maven? The shade plugin, isn't it? That's what we do. We compare, besides everything we had before, we add the shade plugin, and then we add a specific transformer so that we can define what is the main class that is going to be added into the final manifest of the jar. If all the dependencies that you have included in your project happen to have duplicate resources, you have to define additional transformers so that those resources can be combined in something that is actually usable. So it's just a matter of going through the documentation. As a matter of fact, the Shade plugin has really got good documentation, not just on how you use the transformers, but in the case that you need to create a transformer, it's just a plain Java class that you can put in a regular jar in the class path, then this is good. What you do is you package the application because the plugin is bound to the package phase by default. And what about that? We know for a fact that every time that we want to package something nice quickly, we always skip the test, right? If we have very slow test, then we do. But this is kind of the problem. Every time we call package, the test will run. Every single time. Why? If I don't want the tests, then why should I have to pay the price for running the test? And then I have to use this. In the case of Gradle, this is it. There are two ways to define plugins. This is the latest version. We apply the shadow plugin. The name is inspired by the shade plugin. Then it just happens to be, again, an application. You define the class name, and that's it. The shadow plugin is aware of the application plugin and the convention, so there is nothing else that you need to define. The main class name defined by application is reused by shadow, so there is no need to duplicate configuration, which we have in the shade plugin. Remember, the exec plugin had a main class name, and the shade plugin also has a main class name. We can put this into our properties at the top of the Maven file. That's fine. That's no problem. There's just one place when we define the real value, but we had to put the placeholder in two places still. In the case of Gradle, it's just one place, nothing more. And this example just adds a simple dependency so that we know that it's inside there. You just run shadow jar, just creates the jar, and that's it. Or you can even run it directly in full package mode. So I will say it's just a bit better. Finally, let's create an installable application like this. Let's say that we want to target everything as a zip file. We ship it to people that know how to run these things. There is a launcher, a script for Unix or Windows, and all our libraries, everything is right there. Okay? What do you do in Maven in order to make this happen? There are a few options, which is good. You use the assembly plugin. This means that you have to create another XML file called the assembly descriptor, where you define which files you want to put in the zip file, maybe a README, a license, and which dependencies from which scopes you want to be put into the repository of the libraries. And you had to manually create the launch scripts. Yes, you had to. And well, that's a lot of work. Or alternatively, you can use the app assembler plugin, which will generate the launches for you, and will put the libraries in the right place. But you will be missing files like license and README and something else. So, as a matter of fact, you will have to end up with a combination of the app assembler and assembly plugins. More XML to write. Here's how you do it in Gradle. The application plugins does everything for you already. There's nothing else. Everything that is there by convention, you can change by configuration if you want. There are more things that you can do, and here I'm going to show why I believe Gradle will be a much better choice to build projects. Let's go now directly into multi-project, and I'm going to show open mate. There we go. This project is both Maven and Gradle. Say you have a multi-build project like this one. Let's make it bigger. So you define a parent pump like this, some modules, project 1 and project 2. And here in a dependency management block, we define the dependencies that every subproject may use. And then we simply apply it at the end, which means that every single project is going to use JUnit. Good, right? We only need to change the JUnit version in one place, the parent pump, we're happy. So, we have project 1, which defines a simple class that's going to be consume, like this. It reuses most of the metadata coming from the parent, so it's easy to say that. And now we have to always point to the parent. In this case, we have to point to using a relative thing here. Just because we haven't published the parent pump yet. Then project 2 will consume project 1. So we define again the coordinates. We look for the parent. Here's what I was telling you about the property. Because this project is going to be executable, you see the exec Maven plugin. And finally has a dependency to its sibling project, project 1. Right? So what I need to do with my project here is project 2 has to be executable, and I want to run it in order to see if it's actually working. And if everything is fine, then I package and then ship everything that I need. Right? Let's see that. Let's do a Maven cleans from the beginning so that we know that everything is empty. And I'm going to, maybe this is going to give it away in just a moment. M2 repository com acme. Okay, there we go. So I'm going to switch into project 2. What I was told is that I can run this project, right? So if I do Maven compile, let's make it bigger, exec Java, then this should compile my project, isn't it? Let's see what happens. It failed because it couldn't resolve one of the dependencies. It couldn't resolve project 1 jar as a dependency. So everybody have an idea what we need to do here? Install the other one, right? Why? I need it as a dependency. So why do I need to install it? If I just simply say compile or even package here, right? This will create the jar and process the resources. Now I got everything here, right there in the target directory. Why do I need to install it? Why? Everything is right there. Because this is the fundamental thing why Maven is broken in handling these local dependencies. Because everything has to be consumed from a repository. But isn't it the truth that what I need to consume is this thing? And that the information that I need in order to consume it is the POM itself that is sitting right there next to the to project 1? Isn't that the case? Still, I'm forced to push it to a repository. Maybe it's Maven local. Maybe it's another kind of Maven repository where project 2 can find it. Let's do that. Okay, it's pushed. We go back to project 2. Let's try it again. It fails. What happens now? I installed project 1, but project 1 has one dependency too, the parent POM. Let's go and install. How do you install the parent POM? Well, you call install, isn't it? But what happens now? Oh, install the parent POM and project 1 and project 2. I didn't need to install project 2 in order for this to work. Of course, now if I go inside project 2, I do compile exec Java, and it works. It simply prints out this thing. Okay. I make a change in project 1. Source, main, Java, sample, version. Let's make it version 2. Okay? What do I need to do now in order to consume this thing? Call install on project 1 again, and every single other dependency, right? So we're dealing with snapshot releases locally, of course, but these things start to get complicated in a CI environment. And this is the fundamental project we're working with Maven plugins and multi-project builds. We cannot know the exact state of our dependencies.
Here you could use also make dependence or like
A dependency on the reactor. Exactly. So what you're saying is that I have to go one level up and use a magic incantation in the command line, which everybody has to know which one is it, in order to invoke the exec Java plugin on project 2. But remember where we are, at the root level. It kind of works, right? But you have to know this magic incantation. And the last time that I mentioned this, nobody was able to tell me what was the right settings to run. It's just a matter of looking at the documentation. We know it, but we have to look at the documentation. Let me show you now something else. Let's do a clean here at the root so that everything is fine. Then we remove all these temporary dependencies that we just created, right? And I'm going to do it with Gradle. I'm also doing a clean here just so you know that everything is empty. And let's see. Parent file, the equivalent to the parent POM It's right here. You say plugin, apply plugin base so that you can have access to the clean task, nothing more. The root project is not a Java project. Is the parent POM a Java project? Yes, it is. In this case, we don't need to have Java at the root. Okay. Then we say for every sub-project, we make them Java by default. And we define these different repositories. You remember I said something that you could use Maven Central and Maven Local. We're still stuck with JCenter so that we can consume dependencies from the outside. And we also specify dependencies for all of them. This is kind of like the dependency management block we saw earlier with Maven, but just for these subprojects. Just so you know, there is another plugin in Gradle that provides the real a dependency management block like you used to in Maven. Okay, so in this thing, we're just saying JUnit, that particular version for all of them. Good. Let's look at the build file for project 1. Can you find it? There is no build file. Why? Because the child has everything already configured by the parent. There's not even a need for an empty build file. Gradle will know because there is one other file here that I need to share, which is the settings.gradle. This is kind of where you define the modules in Maven. There is, for some reason in Gradle, it has to be a secondary file. But once you do this, it just works. So what about the build file for project 2? We apply the application plugin. We define the main class name. And we define a dependency, in this case, JUnit. We're overriding the one from the parent. We can do this, like in Maven. But we also have a different notation for consuming sibling projects. Okay. Let's go into project 2. I was told that, remember that everything is Gradle clean. Everything is a clean slate. Let's go into project 2. And I was told that if I execute this task, then project 2 was going to run. What needs to happen? Project 1 has to be compiled, and the dependency has to be ready for project 2 to be compiled, and then repackage everything and make it run, right? And it works. Notice that I was at project 2, and project 1 was detected as a dependency and gets compiled. So let's go to the next thing. Oh, by the way, look at the build. It took 1.3 seconds. Let's run it again. Notice the different tasks, the state of each one of them. Nothing was changed, so when I ran the build again, it was much faster. Because it didn't have to compile everything, it just had to run it. Let's change something in project 1. Let's change that to version 3. And we're still at project 2. Let's make a run for that. It noticed that it had to recompile project 1, repackage everything, and boom, there we go. There's no need. If I show you the repository, there's nothing in my Maven local repository. There is no magic Gradle repository happening here. All the binaries are getting consumed directly from project 1. If I want, I can install project 1 and then change the notation here in my build file and say that instead of a local dependency to a project, then it has to be a real dependency with a group ID, artifact ID, and version number. Just like that. The final thing is, say we're changing production code here. Let's change this to Barcelona. Say system, whatever version, and some number, JBCN-conf. Why not? Then we run at project 2 again. And there is. And what happens if we try to run this from the root? Well, I can call clean on the root, and it actually calls clean on the children. So what happens if I try to run this thing here? It will actually invoke the run task on each one of them, project 1 and project 2. But because project 1 doesn't react to the run task, it does nothing. But project 2 does. I could also do a clean again from the top and say Gradle with this special notation, call the run task on project 2 while I'm still here at the root level. and this does exactly what you expect. There's finally another thing that I could show, which is the Gradle wrapper. I can run the same build using the Gradle wrapper file, which is a file that exists right there. And this is what you put on a project in order to be consumed from a CI environment. You point it to the Gradle W script instead of just Gradle, and if it's not there already, the script will download a zip file, put it in the right place, kickstart the build, and continue. And because the zip file is specified in a property file, like this, there is a URL. You can use any URL you want. If you're working in an organization where you need to add more behavior to Gradle, what you do is you repackage your own distribution with additional scripts, with additional libraries, put it in a place where everybody can find it, and then point the Gradle wrapper to that URL. You cannot do this with Maven. So, closing. There are definitely a few more things that I could show. 15 minutes is not enough. In Gradle, we have this feature. In Maven, we have this feature called Maven Archetypes. It allows you to kickstart a project with a predefined set of files. Gradle doesn't have archetypes, but there is another project in the Groovy ecosystem called Lazy Bones, which allows you to kickstart any kind of project, whether it's Maven or Gradle or something else. It's a tool that you can also install using GVM. Then the only thing that you need to find is what is the name of the template. There are many templates out there. Just give it a name, off you go. There is the Gradle plugin portal where you can find many plugins. The site is plugins.gradle.org. There are a lot of plugins that you can find out there. My recommendation is to start with the license plugin. If you care a lot about which licenses are consumed in your dependencies, this can give you a report, but it can also allow you to format the headers of each file so that they conform to whatever standards your company requires. If you need to know if any dependencies are out of date, the versions plugin will do it. It will not touch the build file. Like there's a versions plugin for Maven that can change the POM file. That's kind of scary. Here, this only generates a report for you, and then you're in charge to decide, do I change or not? Shadow we saw, Bintray you published to JCenter, EasyPack for packaging binaries, Java 2 HTML to generate prettified sources. If you need to push to GitHub pages from a command line, then just use the Git here. You can push the results of anything in Gradle. This is really good. Coveralls, if you want to have historical records of code coverage, whether it's Jacoco, Covertura, or something else, really good. ASCII Doctor, if you don't know how to create documentation or you hate writing documentation, first have a look at ASCII Doctor. Next, use the integration with Gradle, because then you can consume information coming from the build and inject it into the documentation itself. Apache Nexus, Sonatype Nexus or Archiva, or even from JFrog, they have access to Artifactory. You can publish to anything you want to. So that's pretty much it. So again, it's a little bit of, I'm running a little bit short of time. There's still a few more minutes for questions. So in case you have them, please let me know. No questions? Yeah, that's okay also. So thank you for your time. I know you guys have a choice. I really like the fact that I'm here talking to you, and I hope that you guys keep enjoying the first ever Java conference in Barcelona. Really a good place to be. So thank you very much.